Hey ladies and gentlemen, this is Miss Humbert here, and today we're going to be doing Unit 7 Notes 1. So we're going to be talking about the fundamental counting principle. So the fundamental counting principle is used to determine how many outcomes for a given situation. Now you guys have actually used the idea of the fundamental counting principle in the past, and you did it in reference to tree diagrams. So let's kind of create a tree diagram like you might have done in elementary school or even in middle school. So to create a tree diagram, we're just going to take each of our options and expand from there. So at a cafeteria, you have several options for sandwich. You can choose either white or wheat bread. So that's to start with. We can choose white bread or we can choose wheat bread. Okay? Now, then from there, you can choose turkey, ham, or roast beef. So from there, I'm going to have three choices. From there, I'm going to have three choices. I'm going to have turkey, I am going to have ham, or I'm going to have roast beef. Turkey, ham, or roast beef. Then it says once you've chosen your meat, then you can choose cheddar, American, or provolone cheese. So then each of those choices has three choices. And it's American, cheddar, American, or provolone. Cheddar, American, or provolone. And that's going to go down on each of these. Okay, so then let's count how many we have. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So there are 18 different ways that you can make up that sandwich. Well, geez, okay, that was a whole lot of work. Imagine if you had to do that for every single math problem for the rest of this unit. Not so fun, right? There's got to be an easier way. So let's take a look at this fundamental counting principle idea. So a tree diagram is used to show or to model the number of different outcomes. So that's if we wanted to visually see all of the different outcomes that there are. However, if we just want to know how many ways there are, and that's kind of the end of it, then we're going to use the fundamental counting principle. So if one event can occur m ways and another event can occur n ways, the total possible ways then are m times n. So then, let's go ahead and let's take a look at how much easier this is going to be. So Farmington High School soccer team has orange, white, and black jerseys. 1, 2, 3. So there are three options for the jersey colors. And then the team uses orange, black, pants. So there's two options for the pants. And then black or white shoes, and two options for the shoes. All right, so then use the fundamental counting principle. So all we have to do is multiply all of those different choices. 3 times 2 times 2. Multiply all of those together and you get 12. So there are 12 different uniforms or 12 different ways that you can create uniforms. Okay, so then that's your final answer. That's all you have to do. If you were to do a tree diagram, on the very end of it, you would have 12 different options. So not so difficult. Let's take a look at number 3. So for number 3, you're picking out a new car for your 16th birthday. You have a choice between 7 exterior colors. So there's 7 choices for the exterior color. So what I'm doing is I'm taking each part's number one at a time. Then there's 8 interior colors. Okay, so then there's 8 interior colors and 4 fabric choices. So then we have 7 times 8 times 4. And you multiply those together and you get 224 cars. So that means or ways. Okay, so there's 224 different cars you can make using all of those options. Next, let's take a look at number 4. So for number 4, it says student council has a vice president, a president, vice president, treasurer, and secretary. For school assembly, they are required to sit in a row on stage. How many different ways can they arrange themselves? Well, there's 4 of them, so let me draw out these blanks. So these represent their seats. Okay, so normally you would think it'd be president, vice president, secretary, treasurer. Well, let's say we don't necessarily have to sit that way. All right, so when we look at the first seat, there are 4 students that we can choose from to sit in the first seat. Well, once we choose someone to sit in the first seat, then there's only 3 people to choose from to sit in the next seat. Once we choose that person, only 2 people to choose to sit in the seat after that, and then 1 after that. So we're really just multiplying 4 times 3 times 2 times 1. which is 24. So there's 24 different ways that they could sit up front. I do want you labeling all of these problems as they are word problems. Okay, so let's take a look, and you guys may not even know this, but what you guys just did was a factorial. So let's go ahead and let's talk about what a factorial is. So a factorial, or n factorial, is the product of positive integers beginning with n and counting backwards to 1. So let's take a look at an example. If you had something written and it said 5 factorial, all that means is you're going to take 5 times 4 times 3 times 2 times 1. Now, obviously, we're going to start at 1, right? We don't want to go all the way down to 0. That wouldn't make any sense. If we went all the way down to 0, then we'd be multiplying by 0, and we wouldn't have an answer. So, let's just not do that, okay? All right, so let's take a look at applying these factorials. So for the first one, find the value of 6 factorial. So to find the value of 6 factorial, all you're going to do is in your calculator, you're going to multiply 6 times 5 times 4 times 3 times 2 times 1. You're going to multiply all of those out together. And when you multiply each of those out, you end up getting 720 when you multiply your way down. Same for 8 factorial. You're going to do 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. So you're going to go ahead and you're going to multiply all the way down, and you can do that directly in your calculator. And when you type that in your calculator, you get 40,320. I always suggest that you try these out on your own along with the note video so that you make sure you're doing it correctly, and then if you're not, it's something we can talk about when you see me next. So let's take a look at this one. Mackenzie is setting up a display of the most popular video games from the previous week. If she places the games side by side and on a shelf, how many different ways can she arrange them? So we have 10 spots on our shelf. So there are 10 spots on the shelf. So when we go to the first one, we have 10 choices for what video game goes there. And once we pick one, we have 9, and then 8, and then 7, and then 6, and then 5, and then 4, and then 3, and then 2, and then 1. So really, this is the same as 10 factorial, is really what this problem is asking, is 10 factorial. So when you punch that in your calculator, you're going to do 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And when you multiply that out, you get 3,628,000. That is a crazy 2. Let me fix that. 628,800, and then again, it's a word problem, so you want to label it ways. So that's the number of ways that you can arrange those video games on a shelf. Let's take a look at this next one. So Zach and Brody are going to amusement park. They can't decide what order to go with the 12 roller coasters in. So the first part, how many different orders can they go on if they ride all of the ride of the roller coasters if they ride each one once? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so there's 12 spots. So when we first get to the amusement park, we have 12 roller coaster options. And then we go on one, now we only have 11. And then we have 10, and then we have 9 and 8. So really, again, this is going to be going down by 1 all the way down to 1. So this word problem, at least this first part, represents 12 factorial. So in my calculator, I'm going to type 12 times 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And when you multiply all of that out, you end up getting 479,001,600 ways. So that's how many different ways you could go on the roller coasters in different orders. That is a crazy lot of ways, right? Okay, so let's take a look at part B. So part B says now you're only going to have time to ride 8 of the coasters. So now, instead of having 12 spots, I'm only going to have 8. And that is 7. So I'm only going to have 8. So here's the catch though. I still have 12 choices when I start off with. So that doesn't mean it's going to be 8 factorial. That means I'm going to start at 12 and I'm only going to go down to 5, and I'm going to stop at 5. So then in my calculator, it's 12, 11 times 10 times 9 times 8 times 7 times 6 times 5. So it doesn't mean it's 12 factorial still. It's not, because we're stopping at 5. So then when you multiply those together, you get 19,958,400 ways. So that's how many ways you can go on the roller coasters if you're only going to go on 8. And frankly, I don't know that I can handle more than 8. Okay, so that concludes your note video for today. Please, please, please make sure you get that Schoology quiz taken. Thank you for listening.